Okay, hi everyone, welcome back to this video series for firewalls. VPN between two firewalls. A common scenario is a VPN connection between two firewalls at different branch offices of a company. All network traffic from one branch office to the other branch office is encrypted at the firewall and sent securely to the other firewall over the public internet. The two internal networks are connected as if a dedicated private link between two branch offices is used. In reality, a true private link is not in place, but instead an encrypted connection over a public network is used, hence the name virtual private network. In this scenario of a VPN between two firewalls at different branch offices, a client computer with a private IP address 10.80.7.5 in one office may use a private address such as 10.65.1.2 to address a computer in the other branch office. Of course, those private source and destination IP addresses cannot be used when the IP packet travels over the internet. The NAT component at the firewall can replace a private source IP address on outbound network traffic and substitute the original IP address on the returned response, but it can't handle the situation when both the source and the destination address are of the private kind. This is where the VPN agreement between the two branch office firewalls comes into play. Instead of using NAT, the VPN software adds another IP header with a public address of the other firewall in front of all IP packets destined for the other branch office. At the other end of the VPN connection, the additional IP header is removed again, and the original IP header with the destination IP address 1065.1.2 is used to travel the last leg on the other branch office's internal network. A similar procedure is performed when a response is sent back, adding an IP header in front of an IP packet is called encapsulation. All packets traveling over the VPN connection are wrapped with this additional IP header. A VPN connection is called a VPN tunnel as shown in figure 4.2. So you can see here a VPN tunnel between two branch offices. So the computer has the IP address 10.65.1.2, our firewall IP address 23.1.1.200, internet branch office 1, branch office 2. So you can see here our second firewall has the IP address of 23.1.2.110, and the computer has the IP address 10.80.7.5. So VPN from the internet to the firewall, very similar to the two connecting branch offices, is the scenario in which a computer on the internet, such as a company user on the road with his laptop, or a telecommuter using her home computer, creates a VPN connection to the company firewall. The purpose of the VPN connection is to dial in security to the office over the internet. So you can see here figure 4.3 VPN tunnel to dial into the office. So the computer has the IP address 10.65.1.2. Our firewall has the IP address 23.1.1.200. The laptop on the road has the IP address 39.4.6.201. In this situation, the VPN connection will not be initiated by the firewall, but by the computer on the internet without a fixed IP address. This means that firewall rules cannot be as specific as was the case when two branch offices created a VPN connection. On the other hand, it is even more important now to realize that the internal network is extended by this newly created VPN connection. The laptop computer on the internet or the home computer dialing into the office are now part of the internal network. This creates a specific vulnerability where attackers may use the current internet connection of the laptop or home computer to connect to these computers and then use the VPN tunnel to jump right into the company network. Additional firewall configurations such as restrictive firewalls is must here. VPN through the firewall. In the third scenario, the firewall is not the start or the end point of the VPN tunnel, but instead the VPN connection runs through the firewall. Examples of this situation are a computer on the internal network that creates a VPN connection to a VPN server on the internet. This can be done to create a secure connection to a business partner. One major difference between the other two scenarios and this scenario is that the firewall is unable to inspect the network traffic that passes in the VPN tunnel through the firewall. This is similar to the restrictions that are caused by other encryption techniques such as SSL connections through the firewall if the firewall uses NAT. Another important distinction between the two earlier scenarios is present. When NAT is used, the start and the end point of the VPN tunnel can no longer just route IP packets through the tunnel, but needs the help of the NAT component of the firewall to translate the source and destination IP address of the IP packets. Not all VPN protocols allow this translation to occur. The two main VPN protocols are point-to-point tunneling protocol and layer 2 tunneling protocol, L2TP. PPTP does not protect the IP header and therefore allows IP address translations when the packets pass the firewall. L2TP uses IPsec to protect the IP packets. IPsec may not allow NAT changes to the packets when they pass the firewall. However, if both the client and the server computer understand the IPsec over NAT extension described in the marriage of IPsec and NAT described earlier in this chapter, then they can also use L2TP, which uses IPsec for encryption through a NAT firewall. So you can see here is a picture of a firewall here in our server cabinet. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.